Alright, in this video we're going to introduce the idea of continuity and continuity in continuous functions at a point. So in this video we're going to determine whether a function is continuous at a given number, so at a particular value for x. So to determine whether or not a function is continuous at a certain number, we have the following conditions for the function being continuous at the value when x equals a. So a could be 5 or -8 or 3.2. But to determine whether or not the function is continuous at a given point, the first condition is that the value of the function at that point has to exist. So there has to be somewhere for that point, for that value of x, where the function actually exists and is defined. So for instance, if there's a vertical asymptote there, that's no good. The second is that the left hand, left hand and the right hand limits need to exist and need to be equal to one another. So we saw that in the limits video, where the left and right hand limits have to equal each other. They also have to exist. And finally, the limit as x approaches a of f of x is going to equal the value of the function at that point. So in essence, what this is saying is both the left and right hand limits have to exist. They have to be equal to each other, and that value that they equal has to be the value of the function at that point. So for instance, here's an example of a generic function that is continuous at x equals a. So first up, the function is defined, so it does exist. Second, the left-hand limit and the right-hand limit are both have a limit value of this value right here. So maybe this is 2. Depends on the scale of the x and y axes. And then finally, the value of the function at that point has to be the same answer as what the left and right-hand limits come out to be. So they have to exist, left and right-hand limits, they have to be equal, and they have to equal the value of the function at that point. Another way to think about continuous at a point is you can draw the function through that point without having to lift your pen or pencil up off the paper. This is a more rigorous mathematical definition. So example 1, explain why each graph is not continuous or is discontinuous at x equals a. So for our first one here, well, first of all, we don't know what the value of the function is at this point. This open circle means it's not defined at that point. So f of a is not defined, so it doesn't exist, so our function has to be discontinuous at that point. Part B, now let's put a point here. So pretty much the same graph, but we've included this point here for part B. So let's see, the function exists at this point. Here's its value right here. It is a piecewise function. The left-hand limit and the right-hand limit both exist and are equal to this value, whatever this y-coordinate is. So let's say this is a y-coordinate of 1, this would be a y-coordinate of 2. So the limit as x approaches a from the left and as it approaches a from the right is 2. And the left and right limits are equal. However, notice the left and right-hand limits, while they're defined and they're equal, they don't equal the value of the function at that point. So the limit as x approaches a for the left and right hand limits don't equal or doesn't equal the value of the function at that point. Part C, here we have the functions defined at x equals a. Let this be 2, y equals 2. However, our left hand limit is 2, our right hand limit would be, let's say, 1. So the left and right hand limits, the left limit and the right limit, aren't equal to each other. They both exist, but they're not equal to each other, and that's not good. All right, finally, part D. Actually, we have quite a few things going on here. Number 1, the function is not defined at x equals a, so that creates a problem. The left and right hand limits are not the same value, so this is a 2 coming from the left, this would be a 1 coming in from the right. Again, the function doesn't exist at x equals a, and our limit then as x approaches a of our function is not equal to what the value of the function is. So a whole lot of stuff going on in part D here. So again, example 1, these 4 a, b, c, d, none of the 4 you would be able to draw the graph of the function without having to lift your pen or pencil up off the paper. So Alright, that about does it for this video. I'll see you in the next one.